And the first set of formulas are that, okay, if I am integrating x to the power n, the integration is x to the power n plus 1 over n plus 1. So this is the formula given in data booklet. I'm just going to show it to you shortly. So this is if I have got, let's say, sine x, the integration of sine x is actually negative cos x. Integration of cos x is positive sine x. Integration of 1 over x is ln x plus c. Integration of e to the power x is e to the power x plus c. Now, when you have got the integration of 1 over cos square x, the integration of 1 over cos square x is tan x plus c. Now, these formulas are all the standard level formulas given in your data booklet. So I'm just going to quickly use these formulas to solve some of the problems. So let's get started with the practice problems. So here are some of the examples that are linked with these formulas that we do in the standard level curriculum. So first thing is that let's say I have to integrate x squared plus 4x plus 7 over x squared dx. Now, when you integrate this, there is no set formula. Actually, there's one formula up here. X to the power n is actually x to the power n plus 1 over n plus 1 plus c. It's also given in the data booklet. So in this case here, what you notice is that there is no proper format of the formulas that you have. So you got to convert this expression into something that you can apply this formula. So what I do is I can just simply do just some of the simplification. So I can just do x squared over x squared plus 4x over x squared plus 7 over x squared dx. Now nx squared and x squared get cancelled, so you get 1 plus 4 over x plus 7 over x squared dx. Now, what you can do is you can isolate these integrals. You can take this as like 1 times dx plus integration 4 over x dx plus integration 7 over x squared dx. Now, when you integrate 1, actually it is x to the power 0. So when you integrate that, you can remember that derivative of a constant is actually constant times x. That constant times x. So here I can remember that, okay, 1 times x is the answer, or you can link up with this formula. So x to the power 0, so it will be x to the power 1, so that this will be x to the power 1 over 1, which is same as x. So this part is x out here. So this is x. And now the next part is 4 over x integral. Now for 4 over x, don't do that x to the power. When I do 1 over x, it is explicitly a formula given because that's where it is ln x as the answer. So if it is 4 over x, it is straight away 4 times ln x. Now lots of times students make a mistake on this. So they take it as x to the power negative 1. And remember that what happened is that when you integrate it is x to the power 0 over 0, which is meaningless. And this formula is valid when n is not equals to minus 1. So what happened is that if you use this formula instead, this is going to be wrong. So the integral of 4 over x dx is 4 ln x. Now coming to the last part, which is 7 over x squared. So when you're integrating 7 over x squared, what you can do is you can simply take 7x to the power negative 2, and then you integrate 7 outside you can take, and you can apply this formula, which is x to the power n plus 1. So when I integrate, I'm not going to retain the sign. So x to the power negative 1 over negative 1, because minus 2 plus 1 over minus 2 plus 1, which is negative 1. So this is the integral of this, which is negative 7 over x. And don't forget to add the constant. So this is the integration of this particular expression. So this is how you do the basic integral of any algebraic fraction. Okay, here is another example on the property x to the power n plus 1 over n plus 1. So when you have x to the power n integral, it is x to the power n plus 1 or n plus 1 plus c. So now let's say here is just a little bit of limiting condition I'm giving. that, okay, f dash x is given as 4x plus 7, and it is given that the curve passes through 2 comma 5. So it is given that the curve passes through 2 comma 5. So it is when x is 2, y is 5, and you have to obtain the expression for the function. So remember that when you integrate the derivative expression, you get the function back. So similarly, what happens is that if you integrate 4x plus 7, the expression when you integrate this is 4x squared over 2 plus 7x plus c. So this is actually your y, or f of x equals to, because this is the derivative expression. If you integrate this, you're going to get the function back. So now our next step is, I just remind you here that I use the property like I could take 4 common, then xtx, here it is x to the power 1. So it become x to the power 1 plus 1, which is x to the power 2 over 2 plus 7 times x, the derivative of a constant, 7, let's say cx constant if you have. The integration is cx. So 7 integration is going to be 7x and plus c. So why this 0.2 comma 5 has been given to us? So the 0.2 comma 5 has been given to find out the constant. So let's say I got the expression 2x squared plus 7x plus c. Now you can input x is 2 and y is 5. So 5 equals to 2 times 2 squared plus 7 times 2 plus c. So what you get is 5 equals to 4 times 2 8 plus 7 times 2 is 14 plus c. So you get c is 5 minus 22, which is negative 17. So you get the exact expression, which is 2x squared plus 7x and minus 17. This is your function expression for this derivative. So now let's take another example where your double derivative has been given to you. So let's say f double dash x has been given to you as 12x plus 4. It's given that it passes through the point 1 comma 6, and the gradient at x equals to 1 has been specified as 12. So this has been given to you as a question and a condition, and what question is that find an expression for the derivative, so for dy by dx and for the function. So here when you have been given the double derivative, so just imagine the reverse process here, f double dash x, f dash x, and f of x. So when you differentiate once, you get the single derivative. When you differentiate one more time, you get the double derivative. So same way when you integrate, when you integrate this, you get the single derivative, and once you integrate this, you get the original function. So when you get 12x, let's say integration of 12x plus 4, I'm going to get the f dash x because it is double derivative. So I'm going to get f dash x expression. So it is 12x squared over 2 plus 4 times x plus c. And this is nothing but 6x squared plus 4x plus c. And it is given that at derivative 1, at the function when x is 1, the derivative is 12. So when x is 1, the derivative is 12. So you're going to put 12 equals to 6 times 1 plus 4 times 1 plus c. So you're going to get c as actually here 6 plus 4 is 10. And so c is going to be 2. So the expression for the derivative that I got is 6x squared plus 4x plus 2. Now, when you integrate this one more time, you're going to get the function back. So f of x is, the integration of this is going to be 6x squared plus 4x plus 2. I'm going to integrate this, and I'll get the function. So when I integrate this, I get 6x cubed over 3 plus 4x squared over 2 plus 2x plus c. So this is your function. Now I'm going to put x is 1 and y 6. So 6 equals to 2 times 1 cubed plus 2 times 1 square plus 2 plus c. So c is going to be 0 here. So that's why your expression is actually now f of x is 2x cubed plus 2x squared plus 2x. And that's it. So this is what you do in order to do backwards. And this is the basics of integration. So now what happened is that in case, I'll just rewrite these formulas that we did. So the integration of 1 over x is um, basically ln x. Integration of x to the power n is x to the power n plus 1 over n plus 1 plus c, where it is n is not equals to negative 1. The third formula was integration of sine x is negative cos x. Integration of cos x is positive sine x. Integration of e to the power x is e to the power x. So integration of, let's say, a to the power x is a to the power x plus c. And integration of the other stuff that is in higher level, it is, let's say if I got integration of sec square x, it is nothing but tan x. And there are other stuff I can write down, but I'm just going to take these ones to explain the properties. That is going to be very, very important. So these are the basic formulas. Now the first technique is that what if these x values that you see, this is a linear function. These all are the linear functions, the x part that you talk about. So what if this x has been replaced by ax plus b? Just like applying some little bit of chain rule skills. Now let us say if I've got integration of ax plus b, how do we do this? If I got integration of ax plus b to the power n, how do we do this? What if integration of sine ax plus b, how do we do this? Integration of e to the power ax plus b, how do we do this? And so on. So if this x has been basically replaced by ax plus b, what is the logic of integrating that kind of functions? So when you integrate this, actually the procedure is pretty simple, okay? The procedure is simple. I'll just explain through one of the reasoning. Now I'm considering, let's say, the derivative of ln ax plus b. I'm just trying to say that, okay, the derivative of ln ax plus b is a 1 over ax plus b times a. Now what happened is that if I wanted to just get this part, the integration of only this part here, I can just divide a this side, which is 1 over a, which is ln ax plus b. The derivative of ax plus b equals to the ln ax plus b is 1 over ax plus b. Now if I integrate both sides, so this derivative get cancel integration with integration, and we get is the answer is ln ax plus b over a plus c. So now what is really interesting is that if you can generalize that chain rule here, okay, so whenever you replace x with, let's say, ax plus b, I'm just going to write down the formulas right below it. So let's say if I've got integration of, let's say, 1 over ax plus b integral, actually it is going to be ln ax plus b. Since the domain has not been specified, you got to put an absolute value over a here. Just divide by the coefficient of x everywhere. So if I replace x with ax plus b, so ax plus b to the power n, if I want to integrate this, it is ax plus b to the power n plus 1 over n plus 1. And then don't forget to divide by the coefficient of x, that is a, because that's what in the chain rule that, like you can see here, multiplier, that comes down. Similarly, if you got sine ax plus b, this will be negative cos ax plus b over a. If I got cos ax plus b, it's gonna be sine ax plus b over a. If I got e to the power ax plus b, it is gonna be e to the power ax plus b over a. If you got a to the power x, actually this integration is a to the power x over ln a. So it's not the same thing. So here it's also given data booklet. This was my mistake while I was writing this. So when you got a to the power, let's say, I'll take, let's say, bx plus c here. It'll be, in this case, it'll be a to the power bx plus c over ln a times divided by coefficient of x. Similarly, if you got like sec square, let's say ax plus b, this integration is going to be tan of ax plus b divided by a. So every time wherever you're getting the x being replaced by a linear one, just divide by the coefficient of x. So that's something which is interesting. So let's take an example of each type now. I'm going to take at least 1 or 2 examples of each type to demonstrate these skills. So the first thing that comes to our mind is the simple ones that involve the ln and log integrals. So let's do that part first. So first is, let's say, if I wanted to integrate 1 over 3x plus 7 dx. So when you do this, now you figure out which of this type is. Okay, so this is a 1 over x plus b type. So it is ln 3x plus 7 over 3 plus c. Now when you're doing integration of, let's say, x to the power n here, it is, if I have, let's say, ax plus b. So for example, let's say I have got, this is 3x plus 7 to the power 20. If I want to integrate this. So 3x plus 7 to the power 21 over 21 times 3 plus c. So this is the second example. So when you're integrating this third one, what you got to do is you got to first convert this into 4 minus 3x to the power negative 5 format, and then you apply the integral. So it'll be 4 minus 3x to the power negative 4 or negative 4, and times the coefficient of x is negative 3 and plus c. So if you wish to write this down, it can be written as 4 minus 3x to the power 4 and 12 times that plus c. So this is the integral of this part. So these are the kind of integrals on the power and the 1 over x function. And now you can like have, for example, if I have sine of, let's say, 3x plus 5 integral I'm doing. So it will be negative cos 3x plus 5 over divided by coefficient of x, which is 3, and plus c. Now if you got, let's say, integral of e to the power of 7 minus 2x, and I wanted to find what's this value. So it is e to the power 7 minus 2x, because e to the power x integral is e to the power x. But don't forget to divide by coefficient of x here. Similarly, if you got like, let's say sec square, integral of sec square 5x plus 8. So it'll be tan of 5x plus 8 divided by 5 plus c. So these are the basic integrals when you link up with, when you replace x with another linear function.